Hello.
Hi, Casey.
How are you?
Doing well. How's it going, gang?
Doing well.
All right. Good to see you.
Make sure you're not peeking over the notes.
Yeah, I'm totally gonna read them. I'm gonna get my iPad.
Yeah. Yeah. He didn't remember. Oh, no.
Does William know how to log in? He does, right?
So you did everything, pretty much. More or less. Yeah.
Not
I
everything.
think Joel and us split it pretty well. Sure.
Mr. Walker, how long do you think the debate is gonna take? Like 40 minutes? 45?
Yeah, probably. Do you have somewhere you got to run off to?
No, I'm good. I was just wondering.
Okay. Yeah. You guys are back in school this week, right?
Today is actually parent-teacher conference day.
Parent-teacher conference day. Are you in school tomorrow?
We have
No.
ISAS the rest of the week.
What's that?
It's a fine arts festival.
Yeah.
With a bunch of like 20 or so schools in the area.
Wow. Okay.
Yeah.
So will you guys be at Fort Worth Country Day, or will you be going to other schools?
It's here this year. We're hosting it. So that's why the school is shutting down.
Oh, wow. So this whole week you're doing that Tuesday through Friday?
Mm-hmm.
Gotcha. What kind of things are there at that?
Multitude.
Arts, yeah.
It's all the arts. It's fine arts, every kind, really.
Okay.
I'm in the band. You're in.
I'm in theater and choir, and there's ballet, and there's like ceramics and photography and
improv.
Improv.
One act plays.
Mm-hmm.
Wow. So is everything scheduled so that different things go off at different times in terms of performances? Yeah. Wow. Sounds like a big deal.
It is.
Yeah.
It's going to be about 3,000 students on the campus.
Wow.
Massive event.
Hey, Chad.
Yes.
Can you guys share that Google Doc with me? You guys have a...
Yes.
And do you guys know if Joel and Willie are going to come into the class too, or are they coming in from home, or do you know?
Joel's coming in from home. I don't know about Willie.
Okay. Was he in? I don't even know if he was at school on Friday.
No, he was somewhere else, I think. I don't know.
Or he left early. I don't know. That was loud. Is this your spring break, Mr. Walker?
Yeah. So we had exams. We have a weird schedule where we have exams for our humanities classes that ended last Thursday and Friday. So the kids are off on spring break, and teachers this week and through Monday of next week.
Okay.
Yeah.
Are you doing anything fun for break?
Not too fun this year. No, I'll be just getting caught up on work, and I'll goof off a little bit, but mostly getting caught up on things. Now, you guys just finished your spring break about a week ago?
We had spring break, then a week, and then this week.
Okay. Oh, so you had a week of school last week?
Yes.
Okay. Did you guys do anything fun for spring break?
Yeah, we both and a bunch of us went to Destin, Florida.
Oh, cool.
That's fun.
It
Is
was
that
fun.
is that a school trip or just something people got together and did?
It was just a bunch of us got together. Everyone chipped in a little bit, and we rented a big house there and just enjoyed the beach.
I think there were 21 of us total,
there were a
so
bunch of
yeah.
us,
Wow. Okay, good.
Has Joel texted you back yet?
Yeah, he has. He was just talking about it. Yeah, I think he'll be on soon.
Okay.
Hey, Willie.
Hey, how's it going?
Pretty well. How you doing?
Good, good. Are Casey and Chad at school? It's hard for me to see him.
Yeah.
Yeah, Casey and Chad. That's cool.
Casey, I'm shooting you an email right now.
Okay. Sounds good.
Willie, did you have a good spring break?
I did, yes, sir. Actually, we're kind of on spring break again right now. I was just in Wyoming this past weekend.
Wyoming?
Yes, sir.
Oh, wow. How was the weather there?
Warm, a little too warm to ski, but it was fun still. Yeah.
Okay, so you were in a skiing area?
Yeah, I'm gonna close my curtains.
Yeah.
Casey, did you get my email?
Yeah, I got it.
Okay, thank you.
No problem.
Willie, are you at home now or are you off somewhere?
No, I'm at home right now.
Okay. Hey, we got Joel.
Yay.
Yeah,
Hey, Joel, how you doing?
good.
Good. You logging in from home?
Yes, I am.
All right, cool. Let's see. Let's see. Do folks know when they're going in terms of the debate? Like who's starting off with the affirmative arguments? Do we know the? I guess I'll try to get an order straight for you guys so I know who we're calling on. Who's starting off on the affirmative? That's either Casey or Willie. Who's going to start us off with those arguments?
I'll start.
All right, Casey's got that. And then the negative probing questions, that's either Chad or Joel. Which one of you guys is going to take those negative probing questions?
I'll do those.
Joel, okay. All right, so then the negative side gets to make their arguments. So that's your introductory argument. So who wants to take that on, either Casey or Willie? Is that Willie's turn?
For the what?
Oh, sorry, I got the wrong team. It's either Chad or Joel. Would that be Chad doing the negative arguments?
I'll take
Alright,
the introduction. Yeah.
Yeah, I got the introduction for the negative arguments. Okay. Then the affirmative side gets to do their probing questions for 2 minutes. Is that Willie? I didn't hear an answer.
Yeah.
Willie's mic is muted.
Yes, I'll do that part.
All right. Willie's got the probing questions for the affirmative side. Okay, then the negative side gets 3 to 4 minutes of negative rebuttals. I don't know if you guys are going to co-do that or if one of you is taking the lead on that. What is the thinking on the 3 to 4 minutes of negative rebuttals? Chad or Joel?
I think it'd be best to kind of co-do it and just see.
Okay. Okay. So I wrote down you both. And then on the affirmative side, you guys are going to make rebuttals. Have you, Willie and Casey, do you know how you want to pull that off?
I think Willie's gonna take the lead, but I might mention something.
Okay, sounds good. And then we end, the negative side gets their closing arguments first for 2 to 3 minutes. So Joel, Chad, do you know how you want to handle that?
Yeah, we're gonna do that.
Both.
Together.
Okay. Got you. And then finally the affirmative has their closing arguments for 2 to 3 minutes. Casey, Willie, how do you want to handle that?
That's gonna be Casey.
Yeah.
That's Casey. Okay. All right. Yeah, I don't know a lot about debate, and I'm just following sort of a set of guidelines given by our debate coach. And so I think no matter what you're debating, at least this group always follows this format. And so the affirmative side always goes first, and then the order is as is. You guys have any questions about, how long you have or anything like that? And I'll have a little stopwatch going. And if it rings, you can just, kind of realize that that's the end, but you can take, a couple more seconds to wrap up. And then at some point, if I need to, I'll just say, okay, we'll have to stop there.
For the probing, that's like questions. Yeah. That's questions and answers, right?
It's actually just probing questions, so you wouldn't expect the other team to answer them at all. All you're going to sort of do is you're kind of pushing back at what you've heard in their arguments, and you're asking, like, I'm not sure why you said this, and can you explain this? So you're kind of pushing for knocking a little holes in their arguments. But during that time, you're only asking the questions, and you're not expecting them to push back or answer them. And if you guys want, when we get to the end, if you want to just go at each other with either arguing back and forth or however you want to do it, that would be fine too. We'll see how it goes. Any other questions before we start up? Okay, so let's start off with Casey. It'll take me a second. Let me get my my phone going here with a stopwatch. So I've got 4 minutes on the clock. And Casey, once you start, I'll hit go, and then eventually you'll hear a ringy ding if you get to the 4 minute mark. So when you're ready, Casey, take them away.
Okay. Our world is faced with a really terrible problem. We, as Americans and as members of the human race, have been caught up in a time where we have been able to do whatever we want with fossil fuels in the environment with no regards to the long-term effect. If we don't take action, we're going to start to see the effects and sooner rather than later. When fossil fuel burns, it releases gases like carbon dioxide, sulfur dioxide, and nitrogen oxide into the atmosphere. These gases are all found naturally in some amount. However, the amount of fossil fuels we've burned alone in the U.S. has increased 20 times since the 1980s, increasing the abundance of these gases in the atmosphere to incredibly unhealthy levels. The major influx of gases has precipitated something known as the greenhouse effect. The greenhouse effect is where those gases in the atmosphere trap the heat and begin to warm up the global climate. The continuation of global warming promises terrifying results, some of which we have already started to see, including the average surface temperature of the ocean heating up 1 degree, which on its own seems small, but when taking into the consideration the massive specific heat of water and the incredible amount of water in the ocean is actually astounding. With heating the ocean comes the destruction of the ecosystems within the ocean and the melting of the polar ice caps and more intense and deadly tropical storms. We can't stand by and continue to let our world fall to pieces while we're standing here. We need to take action and reduce our greenhouse gas emissions and begin to clean up our environment. Nuclear energy is not perfect, but it offers a really great start that will allow us to reduce our greenhouse gas emission, provide for our energy needs in the U.S., and buy us a lot of time when it comes to finding the most environmentally sound way to produce energy and keep our civilization running. Thank you.
All right. Let's see. Willie, do you want to add anything, or are we going to, that's fine if we want to stop there with the affirmative arguments?
That's great.
Good to go? All right, I'll stop the clock there. Thanks. Okay, now we go for, let me just adjust the time now. It's only 2 minutes. So the negative side, Joel and Chad, and Joel's going to start off with 2 minutes of probing questions, and Joel will I'll start the clock for 2 minutes once you begin speaking.
All right, so if there are more nuclear power plants opened, won't there be a lot more problems associated with the imminent increase of nuclear waste from these power plants? And sorry, with this, I thought they were going to answer the question, so I'm kind of having to change mine up a little bit.
Yeah, I understand.
And, could the high amount of money needed to build more nuclear power plants, couldn't that be used to invest research or building renewable energy resources?
I don't mind answering the questions if you want to do it that way.
For right now, he's going to go on and take his time for that, so go ahead, Joel.
All right. And if the world supply of uranium can only last for about 200 more years, is this really a good investment long term to meet the world's energy demands? If more plants are built, how will this affect the health of the miners who are actually mining the uranium? And with increasing technology in the nuclear field, is it reasonable to try and build a bunch of power plants if the technology is going to become quickly outdated? And I think that's all I have.
Okay, that's perfect timing. That's your 2 minutes. So here's the sound of the clock going off. Okay, so we go to the negative side. You're going to make your arguments. So Chad, let me just adjust the clock to 4 minutes if you would need that much time, and we'll start whenever you start. Okay, right. Go ahead.
Joel and I perceive nuclear power as a very risky technology, as evidenced by the multitude of nuclear meltdowns with catastrophic effects, most recently in Fukushima. We see nuclear power as a dangerous, expensive way to boil water and to generate energy. We have 6 primary concerns regarding nuclear power, and they are as follows. Our first concern is nuclear accidents. This is when the core of a power plant overheats and melts down, releasing a lot of radioactivity. A nuclear and radiation accident is defined as an event that has led to significant consequences to people, the environment, or the facility. Examples include lethal effects to individuals, a large radioactivity release in the environment, or reactor core melt. The prime example of a major nuclear accident is one in which a reactor core is damaged and significant amounts of radioactivity released. The perfect example of this is the Chernobyl incident, which was an accident that caused the largest uncontrolled radioactive release into the environment ever recorded for any civilian operation, and it was much more radiation was released than in any nuclear test. Despite the use of restrictive measures and equipment within the facility to prevent these meltdowns, human error is still human error.
My dog.
It's distracting. Human error is definitely going to still remain, and there have been many accidents with varying impacts as well as near misses. Our second concern is radioactive waste disposal. Nuclear reactors and the waste stored on the site are effectively pre-deployed nuclear weapons. Building more reactors simply increases the number of targets, or if added to an existing site, increases the nuclear reactor's capacity for harm. Each nuclear power reactor makes copious amounts of radioactive waste. A nuclear power plant generates annually 20 metric tons of used nuclear fuel. Nuclear power's waste is deadly. It causes every kind of cancer and a multitude of harmful genetic mutations, and there's no known way to permanently contain, dispose, or neutralize it. Nuclear waste will be hazardous for hundreds of thousands of years. Living with nuclear waste is a challenge and constantly emits penetrating radiation, and when not contained, migrates easily into the environment. Not only is it hazardous, it is costly. Consumers of nuclear power plants must pay for the additional costs of cooling, guarding, and storing this waste. Our third concern is nuclear proliferation. Some types of nuclear reactor designs use fissile material which could be used to make nuclear weapons. The term dual-use technology refers to the possibility of military use of civilian nuclear power technology. Many technologies and materials associated with the nuclear power program have a dual-use capability, which basically means that a lot of the waste and a lot of the stuff used in nuclear power plants can be relatively easily made into very destructive weapons if used in the wrong hands, which is why the crisis over Iran's nuclear activities is a great case at this point. Our fourth concern is the high cost. Nuclear power plants are incredibly expensive. A new one could cost upwards of $9 billion. If we want to reduce the climate impact on electric power generation in the United States, there are less costly ways than expanding nuclear power. Our fifth concern is potential attacks on nuclear power plants. Nuclear power plants pose especially high risk of danger by terrorist attack. Though rendering the nuclear power plant obsolete by some means would be costly and harmful to the economy, the real risk lies in the use of nuclear power, specifically to harm others by making destructive nuclear devices. Our sixth and last concern is uranium mining. Workers are exposed to not only to fine particles of uranium, but also to radon gas, which the miners inevitably inhale, causing cancer and other health issues. Large amounts of water used in the mining process. All
right, Chad, we're going to have to stop you there.
That's basically
good job.
We had a lot there.
Okay. Sorry. Yeah, you did. And because my dog barked, I gave you a little extra time on that too. Sorry about that. We are now going to, that was our negative arguments. We're going to go to affirmative side has probing questions for 2 minutes. So let me set the clock for 2 minutes. And I think, Willie, you are going to go after them with some affirmative side probing questions. When you're ready, Willie.
So, I mean, the world needs energy. We need energy, and there's really only two ways that we can get it. We can get it from clean, renewable energy, which we've been doing nuclear power plants, or by burning fossil fuels. I kind of read it's the only way humans have ever learned to get anywhere is by leaving something behind. And by using fossil fuels, what we're leaving behind is really toxic greenhouse gases. This whole debate really comes down to climate change, because what happens with climate change is that our world is changing, and it's a lot more volatile than we think. I mean, just this past weekend, I was skiing in Wyoming during the height of spring ski season, and there was no snow on the ground. In Fort Worth, Texas, we had a cool winter. We had a nice winter the whole time. It was 70 degrees most of the time, and then for 1 week in February, it dumped, and no one was prepared for it. The weather is becoming more volatile, and everything's changing, and we don't really know what to do with it. So the only thing that we can do is to make sure that we have a source for clean energy. I know it's cheap to burn fossil fuels, and economically it's probably the better thing, but looking forward, it's our duty to do what isn't cheap, what isn't the easy way out. As humans, it's important for us to do what's hard and what takes more sacrifice. And with nuclear power, it's so important to do it because it leads to a world in which these problems are lessened, in which we have a more stable climate, in which we have a more stable world to live on for the next thousands of years. About it.
Okay. So let's see. We are going to go to the negative rebuttal. So you guys have 3 to 4 minutes. And I believe that was Chad and Joel are both going to take that on. And let me set the clock for 4 minutes. So this is the negative side pushing back on anything they want to push back on. And then the affirmative side will have their chance to rebut for 3 to 4 minutes. So once you guys start, I'll hit the clock.
All right, I'm going to go ahead and take it first, Chad. So one of the things that William first said was that nuclear energy, he included in the group of renewable energy and clean energy, and it's definitely not renewable. We have a finite amount of uranium on our planet, and so it's not a renewable energy. And then it is a lot cleaner than fossil fuels. Fossil fuels are pretty terrible, but that doesn't necessarily mean that there's only fossil fuels or nuclear. We can go a lot into renewable energy. I think Denmark gets 39% of its energy from wind energy. Germany gets over 6% of their electricity from solar. So there's countries that use renewable energy and clean energy a whole lot, and United States can try and follow that path.
It's not just a function of, it doesn't have to be global warming or nuclear waste. There's a lot of different opportunities, a lot of different things that we can do because, global warming is bad and fossil fuels have bad side effects, but so does nuclear energy. And I think there are other alternative energy sources that don't have near the repercussions that nuclear does or that fossil fuel does for that matter. So,
and there's also a lot more improvements in renewable energy. They're now designing solar panels that are completely transparent, so all those could be installed in windows. And think about all the buildings with huge windows. If those could be used to make energy, it could at least supply the energy that the building itself needs for lighting, and hopefully supply some of the power grid with extra energy. And then using nuclear energy is kind of risky, and it's a big investment. And so if we're starting to move more towards renewable energy sources, it's not really worth it to try and invest a ton of money if we're just going to move away from fossil fuels and nuclear energy. We already have a lot of fossil fuel plants in place, and it's cheap to use right now. And so we can try and use all that money to try and kickstart our way into using renewable energy, and it'll help improve the technology and the efficiency of it and really get us going down that path, which is ultimately what we have to do, because neither nuclear nor fossil fuels can sustain us for thousands of years. It's hundreds of years, and then we have to have a solution by the end of that. You have anything else, Chad?
I think you said it. I think you said it all.
Okay, good. Let me cancel that. All right. So we go to the affirmative side gets their chance for rebuttal, and you've got 3 to 4 minutes, Casey and Willie. I think Willie was going to take the lead on this.
So one of the big things I'm hearing over and over again is nuclear waste, and it's a huge issue. And I will concede nuclear waste is a huge problem. I mean, we learned in class there are plans to go forward with it and to use nuclear energy as a leg to reach into really high efficiency renewable energies. We have to solve this problem of waste, and they're doing that. They have the mountain plan, and they're thinking about it, and they're addressing the problem, which is a big deal. But it's important to realize that we're not talking about like mountains and mountains of nuclear waste. It's every 2 years nuclear reactors spit out a waste, but it's not the size of a huge football stadium. It's not a massive thing. It's small, it's concentrated, and for our purposes moving forward, it can be contained. You talked about renewables in Denmark and Germany, and I think that's a great example of how renewables can make a difference, but it's honestly exclusive to the size of those countries. You have wind farms in Denmark. Denmark's like the country that's like the size of Texas. We have wind farms in Texas. They supply power to different cities in Texas, but the problem is that you can't have wind farms that supply power to the national United States. We're so massive of a country. You can't have huge renewable sources that have to travel thousands of miles. You can have like wind farms in Texas that power New York City. You need localized forms of high intensity clean energy. And that's really why going forward, nuclear is one of the best things to do, because you can put a nuclear reactor outside of, somewhere outside of New York, and it can power all of New York, stuff like that. Also, one last thing you addressed was accidents. And I don't really like this thing because, I mean, looking back on it, let's like turn back the tables. We've had 2 critical nuclear accidents since I think Chernobyl was in the early 1980s. So that's 30 years. I mean, if you really look at the grand scale of things, that's 1 nuclear accident every 15 years. And now, while that's not good, it's coming down. We have safer precautions. The new nuclear reactors in France have automatic critical sustaining. It's very hard for those reactors to go critical. So new designs coming forward really make accidents kind of a thing of the past. And there's only been 2 critical ones so far. It's important to remember that. Casey, do you want to say anything?
Yeah, I think everyone in this room agrees that we need to find a way to use renewable energy in the most effective way possible. But if we put off renewable energy for fossil fuel so we can research, nothing's going to change. We're going to keep using fossil fuel and everything's going to keep getting worse. We need to do something now so that we can move forward for the future.
All right. You guys have one more minute. Are you done though?
Also, we talked. One of those 6 points was, you said that nuclear reactors posed problems for nuclear bombs, and I wanted to kind of tie that back into the waste point. It's not like there's 50 nuclear reactors in the U.S. and they do spit out waste every 2 years, but the thing is, it's not like there's just a huge pile of nuclear waste off of I-30 that a terrorist can go and take what he wants and leaves. And I know that there's been concerns with the security of nuclear waste, but you have to remind yourself that we're not talking about there's not a massive amount of it. I'm sure that all the nuclear waste that we've accumulated could fit into a pretty localized and small space. It's very toxic and it's very awful for all humans to be around, but it's localized and it's small and it's containable.
We also have to consider that the fuel for nuclear reactors is only enriched to 2 to 3%, where bombs are enriched to 90%. So even if a terrorist were to take it, it would not be as effective as an actual enriched nuclear bomb.
Okay, good. Casey, you may have been. I accidentally got a phone call coming in on my phone. That was what that sound was earlier, not the time's up. So sorry if that was confusing. Good job, gang. We are going to the negative closing arguments. And so, Chad and Joel, you have 2 minutes to push your point for the negative. Wait, sorry, I got to set the clock for 2. Okay, once you're ready, I'll hit go.
Do you want to start out, Chad, or do you want me to?
Yeah, my computer just restarted. I'm trying to get back to my notes, so it'll take 5 seconds.
We can take a little delay for that because those things happen. So.
Almost there.
Are y'all getting any feedback from my mic, or is it okay if I leave it on while Chad's talking? Or
Mostly we haven't. Occasionally we've picked up something, but you've seemed to correct it pretty quickly.
Almost there. And all right, we're good. I think as this argument has been pretty much just deciding which is worse, nuclear power or fossil fuel, and I think our side agrees that both are pretty bad, and we think that nuclear power is in some ways the worst alternative fuel, and it's not really what we could use. There are so many different types of energy, types of ways of getting energy, that we don't think nuclear power is necessary. If it was necessary, if it was either we have fossil fuel or we have nuclear power, obviously you choose nuclear power. Fossil fuels are not near as potent, don't do near as much to the environment as nuclear power, but nuclear power isn't just the only alternative energy source. We could definitely thrive as a society without having to worry about nuclear waste, without having to worry about all the multitude of complications that arise when you're dealing with nuclear power. And we just don't think, we think that the risks outweigh the benefits of increasing the amount of nuclear power plants in the United States. Even though maybe Willie did say that there wasn't that much nuclear waste, if you continue to use nuclear power, there's going to be more and more nuclear waste. And even though maybe it's not as much as maybe the amount of carbon dioxide that's emitted by fossil fuels, it's a significant amount, even though it's not multiple football fields.
Chad, I found a number on the waste.
Did you?
20 metric tons of nuclear used nuclear fuel are produced annually by one power plant. So it is actually quite a bit. And the fact what's so bad about it is that it builds up because it's radioactive for 1,000 years. It's not safe. So that keeps building up. And if we keep increasing our use of nuclear energy, that's going to just keep rising.
Yeah.
Sorry, I didn't mean to interrupt you. You can keep going.
No, I think that was pretty much done there. So.
One thing we didn't get to touch much on was the nuclear or uranium mining. And that's really dangerous because not only is it dangerous for the workers, but they use a lot of water.
All right, so yeah, that's our time on that one. And we may get a chance for you to. Yeah, go ahead.
Okay, so they use a lot of water in the process of mining the uranium, and a lot of it's just in kind of underdeveloped countries, and so they just put it back into rivers and lakes, and so that's putting radioactive material and not only damaging animals and plants, but also the people that have to drink that water.
Okay.
So that's it.
Yep. Thank you. All right. So our closing arguments for the affirmative side, Casey, Willie, I'll start once you begin.
Okay. Nuclear energy actually offers a great advantage to the U.S. There will always be a risk with nuclear energy, but there have been significant advances in the nuclear field, as shown by the U.S. naval submarine fleet. There have been nuclear submarines in the U.S. Navy for 61 years, and there has never been a nuclear reactor disaster aboard any of the subs. Not only that, but reactors have to survive in extremely harsh, changing environments, and they can't corrode or wear down in any way, or else it would be deadly to the ship. Recent advancements have created nuclear submarine fuel that lasts the entire life of the ship, approximately 33 years, with no human maintenance, which is significantly longer than burning coal lasts. These advancements show considerable promise for nuclear power as a serious source of energy. Another reason the U.S. should build more nuclear energy power plants is because it provides a significantly more efficient way to produce energy. 1 kilogram of coal produces approximately 8 kilowatt hours. 1 kilogram of mineral oil produces approximately 12 kilowatt hours. And 1 kilogram of uranium-235 produces approximately 24 million kilowatt hours. And I think there's a significant difference there. Lastly, when considering whether or not to create more nuclear energy, the U.S. should consider the effect of our current source of energy on the environment. In 1947, the Bulletin of Atomic Sciences created a doomsday clock to illustrate how close they felt the world was to destruction through unchecked violence. Since that year, the Bulletin has posted updates, moving the clock closer to and far from midnight. Can I keep going? I'm almost done.
Yep.
As they see improvements and regression. It's 2015 and the clock is 3 minutes to midnight. The Bulletin states that despite some modestly positive developments in the climate change arena, current efforts are entirely insufficient to prevent a catastrophic warming of the Earth. If we don't take decisive action soon, we will find that the clock strikes midnight. It's too soon for us.
All right. Why don't you guys give it up for each other? Good job. Does anyone have any last-minute things they want to add? We'll consider our debate officially over, but anything you were thinking or didn't get a chance to say that you wanted to say?
You guys kept bringing up mining, and I was the entire time I was thinking that mining coal and fracking the earth for natural gas isn't exactly environmentally friendly either, or healthy.
Yeah, that would have been a good point to make.
Yeah, I was surprised y'all didn't bring that up. I was like prepared for it.
One thing I wanted to add that I was going to at the end of the closing argument was that, like, I think we're both kind of agreeing that fossil fuels and nuclear energy is kind of like a stepping stone to really high efficiency renewable fuels like solar and stuff like that, and like maybe nuclear fusion. And I don't know, one thing I was kind of wanted to add at the end was that, like, if we had to use a stepping stone to get to like the highest efficiency place, we should use, like, nuclear energy would be the cleanest one we could use for the Earth. That's what I was going to say at the end.
Okay. I want you guys to just send me a quick email letting me know if you think there was a winner in the debate, and how you think you worked with your partner for the debate. So just send me a quick email, and or any feedback on the debate too. Like, did you enjoy the debate? Would you have done it a different way? Does everybody have a laptop in front of them? I think so, right? Yeah. So send me a quick email, thoughts about the debate.
Mr. Walker, a quick question for you. How far do you think
ahead.
we are from nuclear fusion reactors?
Yeah, it's a tough question. I still think it's a pretty long ways away just because it takes so much heat to get the fusion to happen. You really need temperatures like on the sun. So I think they're trying to figure out a way to hold it in space without melting whatever device that's holding it together. So yeah, it's a pretty exciting technology.
I did a research project on it, like my sophomore year, and they like the device they're using is called like a tokamak, and it's like a metal donut, and they
Yeah.
use they use like electromagnetics to like float the fuel in between, so like it's not touching anything, because the biggest problem was
Yeah.
anything it was touching would also turn into plasma as well. So that like
Right,
really
right.
make it float around this donut. I thought it was awesome.
Yeah, it sounds really cool. All right, so Willie and Casey, wrap those things up and send them on.
I just sent you mine.
All right, got it. All right, Casey, have you hit send yet?
Yes, I just hit.
Okay.
Yes.
All right, great. We're all good then. That was kind of an interesting way to do it with just 4 people because I think you guys got to participate a lot more than before. The other way I did it, it actually worked out well because there were 4 people on each team in the other debate, and so people had less voice in the thing. I don't know how you guys felt about that. One thing I wanted to point out that the pro side didn't make a point of that they could have bashed the negative side against. Um, I think the pro side could have made the point that natural gas or coal or those things are dangerous too. Like natural gas explosions happen all the time. Houses blow up. They make the news, and people die from them too. Is Casey? What are you doing, Casey?
I live out by a natural gas compressor. I live in Weatherford, and there's a whole bunch of drilling. And the other day, one of the compressor stations caught on fire, so that would have been a good story.
Yeah. So, and I think you guys did make the point that nothing out there is a magic bullet yet, and everything's got its problems. But you could have bashed on the natural gas or the coal plants just a little bit because those things can blow up. Miners can get black lung. There's all kinds of problems with it. So it's not clean no matter how you do it. And I think some of that was included in your introductory arguments. But all right. So anyway, good job on that. That was fun. Can you guys flip over to a Google Doc that is shared with you guys? That's called. Let me see what it's called, so you can all go to that. It's MSON Chem Projects, and open that up for me. And I know Casey, I believe, and Joel have actually already been on there and picked their next project, but go to there anyway. And Willie and Chad, I'm not sure if you've seen this yet. Can you find it in your Google Docs? MSONATIC Chem, CHEM projects. Do people see that? Let me get a thumbs up if you're good to go there. Okay. So on the first sheet is sort of a topics. It's just a whole bunch of topics. We're going to do another project, but I want it to be non-nuclear this time. So if you kind of just look around there and find something that maybe seems interesting, and I don't mean that this is all inclusive either, but there's tons and tons of topics out there that you could become the expert on and then make a presentation to the class. And if you were interested in seeing what other people have chosen, but I mean anything from like how does sunblock work? How does it block UV light? That was one thing that I know growing up I didn't really have access to that you guys now think of as just always there. Or, you could look into the chemistry behind cell phones. I think our author of our book has mentioned that a little bit. There could be medicines or plants or different types of venoms or poisons from plants, or just about anything out there has got some interesting chemistry behind it. So I'm looking for you guys to be excited about something and want to find out more about it and want to do a project on it. So if you flip to the second sheet on that, it says student projects. Basically what that is it just let me know if you think one of those interests you or excites you. So Casey, it looks like you think nanotechnology, and Joel, caffeine. Does that sound like something you're still interested in doing? Okay. That could be cool. Yeah, go ahead, Casey.
What are the demonstrations?
So towards the end, we're going to do demonstrations. So that's a ways off. You're going to, in theory, you'll do this project. You'll do a project on an element, and then the last thing will be a demonstration. So I'm hoping that you'll find something that's really cool and do a chemical demonstration and film it, and then present it to the class. So there are tons and tons of really cool demonstrations you can do out there. You can find some that inspire you on YouTube, or your high school chemistry teachers may have some good ones, or I have lots and lots of good demos too. But it's something that you would do and film, and then sort of make a presentation as you do it, so that that's your final project in this class.
Okay.
So that's a ways off, but that's out there coming up.
Do you think it'd be possible to, like, if caffeine's not enough to do like 5 to 7 minutes, to like add nicotine maybe, or like another drug?
Yeah, that might be interesting to compare. You could do the chemistry of them, like, show their structural formula and maybe think about how they interact with nerves, and, what it is about them that makes us, or humans, that how they get addicted to them. So I think there's plenty there. And you can decide the caffeine may be enough, or it could be that you decide you want to parallel that with nicotine, which I think would be fine. Willie, you got some thoughts?
I just stole nicotine off the board, so.
Okay.
Go for it.
Sorry about that.
Okay. Mr. Walker?
Yeah.
Mr. Walker. I'm interested in ibuprofen, which is like the painkiller in Advil. Is that cool if I do that? Because I know that wasn't on the list of things.
Yeah, but that list is definitely not meant to be all inclusive. So do ibuprofen, and you might find some other things similar to it, and you can look at their chemical structures. And I want you guys to do something you really think is exciting and fun, and I'm sure there's a good bit of stuff out there. So Willie ended up grabbing caffeine. I mean, Joel's got caffeine, but Willie's got nicotine. So Joel, I'm wondering, I think in terms of caffeine, there are ways to think it through, though. And if in your research, if you're feeling like there's not enough, there are definitely some other things you can do to and get in a little more. You could compare it to just about anything out there.
All right.
There are probably some other. I mean, you can think of the different sources of it, and I think that you'll find that there's some good stuff out there for a 3 to 5 minute presentation, and always try to pull it back to the chemistry side of things. I think. Let's see, Willie, did you put it in the document, or do you want me to type that in there that you want to do?
I put it in there.
Oh, where'd you put it? Because maybe you have it in a different place. Go to the student projects. I don't see you on there, Willie. The second sheet with your name and then topic.
I see it on there.
On the
really?
last one, in between Jad.
Okay. Okay. You know what? My computer's telling me trying to connect, so maybe it's actually having some issues trying to connect with Google Docs. So if it's in there, it's in there. So that's Casey. So everybody's got a project for the future going on? Okay. Mm-hmm. Did you guys get my email? That's the author of our book, Sam Keene, is going to be able to join class?
Yeah.
So that's very cool. I would encourage you guys. Do you guys have much homework this week, or is this kind of like a really relaxed week for you guys?
I have a ridiculous amount.
You have a ridiculous amount of homework. So your teachers gave you homework last week, and they expect you to do work over this week? Yeah.
Yeah.
All right. Well, figure out a way to do some work for me too. So reading ahead and Disappearing Spoon would be good, and also doing some planning for this project here. I believe I've shared a Google Doc with the expectations, but it's pretty much like before. You can either do a prepared project or you can do something live. And did anyone? I'm trying to remember. Did anyone do it live last time? I know Casey did a project. I'm trying to think back. Or did everybody do a filmed thing?
Yeah, I think we all did pre-recorded.
Yeah. Okay. I think that's a good experience. You can make a decision if you want to keep doing that, but I think that's a good experience and a good way to make I think it's just a good experience all around. Focus on really speaking very clearly into the camera, and I think if as you're going through the editing process, if you're hearing the sound is just really weak, then I want you to just do the sound over again. So lay down a really good volume. If you need to, go to a super quiet place to do it, but just make sure your voice is presenting very clearly and very forcefully. Let me see. Syllabus-wise, I'm just going to flip to the syllabus real quickly. Our students, most of the students are on spring break. You guys are in sort of an intermediate thing. We don't have class this week on Thursday. We don't have class on Monday of the next week, but our next class will be April 2nd on Thursday, and that's when we'll all get together again. Any questions from you guys?
On this it says it's due the 3rd, but is it actually due the day we meet or the day after we meet? The presentation.
So yeah, I need to change that. We're not going to be ready to make presentations the day we get back. So I think what we'll do is mostly do some Disappearing Spoon discussion, and then probably begin the projects 2 weeks from today. Does that sound more reasonable?
Yeah.
So I'm going to let you guys go. Thanks for coming in on a day you didn't have school, and good luck on your, what is it? It's all of the stuff that's going on this week with the arts and performing stuff. So good luck with all that.
Thanks.
Thank you.
All right. See you, gang.
Bye, Mr. Walker. See you later.
Good job.
Thank you.
All right. Bye-bye.
Bye.